Today our focus is going to be on angles of elevation and depression. We've done a little bit of work already with trigonometry, and this is another application to use with trig. Angles of elevation and depression can be used to calculate distances. So if we look at our first drawing here, and this will follow along with your notes that you have, this worksheet actually from class, our angle of depression, this here, in order to find that angle, what that is the angle that's formed by the horizontal line, so this line here, and the line of sight to a point below that line. So again, we have this horizontal line, our sight line, so we've got our little person here in our balloon looking down to this object on the ground. So think about the word depression itself. What it means to be depressed, we're down. We're down in the dumps. So think about, again, the horizontal line looking down, and that's where we have this angle. Something else to note with this diagram is that this horizontal line is parallel to the horizontal ground below. So what do we remember about parallel lines and those angle properties? This angle of depression here will be congruent to this angle down here with our ground and our object, because of the properties of parallel lines and our alternate interior angles. So again, these two angles here are congruent. If we look at our other example to the right, this time we're looking at the angle of elevation. The angle of elevation is the angle formed by a horizontal line, so this line below, and a line of sight to a point above that horizontal line. So again, think about what it means to elevate. We're looking up this time, so we have our angle of elevation here. A special note is that the angle of elevation or angle of depression is the angle between the line of sight and the horizontal line. It is not that vertical line itself. Let's set up an example on our next slide. To find out the altitude of an airplane, that's what we're looking to do. So let's recall that altitude is simply another word for the height. And if I'm looking for the height of that airplane, I'm looking for this vertical distance here. So maybe I'll go ahead and call that x. Now, in thinking that we're going to use trigonometry, I also may make a note to myself of my SOHCAHTOA, just so I have it handy as I set this up. So we're just going to set up this problem and we'll finish it up in class with our calculators later. So let's just continue on with, again, if we look at our horizontal line here, we're looking down at this object below, then we know this is our angle of depression. It's 26 degrees. Using properties of parallel lines, I know that it's congruent to this angle here, so I can also write 26 degrees at this angle. Now, think about my trigonometry. Where do I have information? I have information with the x, which will be from my angle opposite that angle. And I also have information here, which is the hypotenuse. So looking at opposite and hypotenuse, opposite hypotenuse from my SOHCAHTOA, I need to use the sine trig function. So to set that up, it will look like sine of my angle measure of 26 degrees. That will be equal to the opposite, which is x, over the hypotenuse, which is 7. Algebraically, if you just look at the 7 in the denominator, I need to multiply both sides by that 7 in order to clear that. These over here go away, and if I rewrite this, I know that x will be equal to 7 times sine of 26 degrees. Now, we'll solve the rest in class, but if I go ahead and look at my calculator, typing in this 7 sine of 26 degrees, I will find out that x is approximately 3 kilometers, which means that the height or altitude of this airplane is 3 kilometers in the sky.